I covered number systems in my previous video, and if you haven't seen that one yet, I recommend watching it first. Essentially, while binary is base 2 and decimal is base 10, hexadecimal means base 16, meaning it uses a base of 16 and 16 unique symbols. You may be wondering, how do we make 16 symbols? I mean, base 2 uses 1 and 0, but we only have 10 Arabic numerals to work with. The answer is that computer scientists are lazy, and instead of making new ones, we just use capital letters to represent 10 through 15. These may seem a little confusing at first, but they behave exactly as an extension of our current number system. Just like adding 1 to 7 would give you the next symbol in line, 8, adding 1 to 9 gives you 8. If you watched my video on binary, you can apply the exact same formula here using powers of 16 instead of 2. I only use 2 digits because using more would overcomplicate things, and you'll see later that 2 hex bits is more than enough. Let's try 7F as an example. We multiply each digit by their corresponding power of 16. Let's do the easy one first. 16 times 7 is 112. Done. But what about F? If you refer back to our original chart, you'll remember that each letter corresponds to a number 10 through 15. F just happens to be in slot 15. Since we're converting to decimal, we just multiply 15 times 1, which is 15. 112 plus 15 is 127, and we did it! 7F in hex is equal to 127 in decimal. Here are some practice examples. Try and see if you can convert them yourself. You can pause the video if you need to. If you're confused by the first one because of the leading 0, just remember that hex functions just like any other number system. And like 0, 1, 2, you can ignore the leading 0 and simply write 12. Computer scientists use a leading 0 to signal the start and end of a byte, something we'll get into later in the video. You might be wondering, why use hexadecimal at all? Why not just use binary or decimal to store information? Well, say you wanted to store a really big number on a computer. You could write it in binary and save lots of time converting between what's stored on the computer and what you have written down, but it gets long and messy fast. Hexadecimal not only is significantly smaller and more efficient than binary, it's even shorter than decimal and looks much cleaner. Okay, but why 16? Why not 15 or 18 or even 20? Well, if you know your powers of 2, you'll realize that 16 is equal to 2 to the 4th power, and this is no coincidence. 2 to the 4th power is the same as writing 2 times 2 times 2 times 2, meaning 1 hex bit is equal to 4 binary bits. That means that using only 2 bits of hexadecimal, you're able to store a whopping 8 bits of information. An added bonus of this system is that since each hex represents 4 bits, you can store 16 times 16 or 256 different possible numbers in 2 hex bits. This also makes converting between binary and hex much easier, and it's the reason it's used in computer science and machine code. A byte is another word for 8 bits, or 2 hex digits. It's the smallest amount of information a computer can work with on 8-bit computers. However, more modern computers work with 32 or even 64-bit architecture. One place you might have seen hex before is in color codes. By assigning each color value 2 bytes, you can store over 16 million different colors. While we could store each value in binary, it would be a pain to have to write 24 ones and zeros compared to a simple 6 hex digits. We could also use decimal, but we get much uglier numbers for our more common values like FF and 7F. A number system requires the right balance of length of the string and number of characters. While we could use base 1 if we could only remember one symbol, we'd have to write 147 ones to write the number 147. It's basically a worse version of tally marks. On the other end, we could use something huge like base 263. It would make numbers much smaller to write. 147 would only require one symbol. However, it requires that you memorize 263 unique individual symbols. You can technically make any number a base, even decimals, negatives, irrationals, complex, or even some twisted Frankenstein combination of them all if you're feeling especially evil. However, we're not going to be getting into that because I'm honestly a little scared. If I confused you, make sure to like and subscribe as it helps out a lot. See you in the next one.